Welcome back, students. In this video, we are starting a new lesson number 7, alternating current. This lesson is mathematically a little intensive. We will be doing quite a few derivations in this lesson, and that way it could require a little deeper attention from you when you take the class. So focus on this lesson. It's a very important lesson too, because there will be lots of questions from this lesson, lots of concepts too. So unless you focus on this lesson, it could become difficult for you to understand it a little later. Okay? Most of the people don't understand this lesson well because they don't focus. So I wanted to focus on this, and it is also, as I said, is mathematically intensive. But before we get into that, I want to just give you a brief introduction of what AC is. Alternating current is shortly called as AC. When you have a voltage which produces alternating current, then you call it as AC voltage. It is different from a DC voltage. The battery you buy from the stores is a DC voltage. But what you get in your houses is AC voltage. Then why are they not giving you DC voltage directly to your houses? When you take a connection from TNAB, then why are they giving you only AC voltage? The reason is that even though you produce DC voltage, it is difficult for you to transmit the DC power over long distances. A battery can help, but I cannot continuously produce DC and then transmit that power to long distances without incurring a lot of losses. The process of transmitting energy and power from one end to the other end, if the distance between them is too much, then if you use DC, it would be very inefficient. Most of the power that you generate would be lost in the transmission itself. So if you want to give somebody 1,000 rupees, you lose 999 rupees along the way, and only 1 rupee would reach that person. You don't want that to happen. You want almost 1,000 rupees to reach that guy. Even if somebody takes 10 rupees, 15 rupees along the way, then you still want that guy to get 990 rupees or 985 rupees. So that way you can reduce the losses. You try to give 1,000 rupees, and that guy is going to receive 985 or something, which is okay. Or it's like sending money through money order or through courier. It's like that. Suppose somebody in some other city, your friend, wants 1,000 rupees. And when you try to send it as a package, you just probably put it in an envelope, and then you go take it to the courier, and at the courier, and they will charge you something, maybe 30 rupees or 50 rupees, depending on the package. So to send 1,000 rupees, effectively you may spend 1,050 rupees, which is okay, because the extra money that you spend is less. But to send 1,000 rupees, if you need to spend, say, 10,000 rupees or 20,000 rupees, if you spend 20,000 rupees and if that guy gets only 1,000 rupees, then that is atrocious. It is extremely inefficient. So that is exactly what happens in DC. When you try to transmit power from one end to another end, which is at a long distance from the generating end, then there will be a lot of losses in the transmission if you use DC. AC avoids this. AC reduces the losses, reduces the expense, the extra expense you have to incur. It's like sending it to a courier, which is okay. If you want to send 1,000 rupees, you spend only 20 30 rupees or something. You're fine. You're okay with that. So AC is like that. So almost all, or I shouldn't say almost all long distance power transmission takes place only through AC. And AC can also be used, the concepts of AC, not the AC, that power that you receive from the terminals. The concepts of AC can also be used to tune into a particular TV station. For example, like when you surf from one channel to another channel on your TV, like you go from Sun TV to KTV or some Raj TV or some other TV, when you switch the channels, and actually you're using the concepts of AC to tune into the new channel. All that we will study later as we progress. But I want you to understand that AC voltage is very helpful in transmitting power over long distances. If you are going to start a power transmission company, then you would want to generate that power as AC power, not as DC power. You want to give the power in AC voltage, not in DC voltage, because only that way you can transmit the power efficiently with minimal losses. I want you to understand that part. The way we represent AC is this. For example, you know how DC is represented. DC is represented like this. It's constant voltage. Okay, like that. Even if you're going to vary this, then it's going to be like this. Okay, in this case, the voltage is not going to be constant, but you would have maybe like at some point you have 2 volts, 3 volts, 4 volts, 5 volts, and then bring it back to 4 volts, 5 volts, and then 0 volts. So this can happen, but the current is flowing in only one direction in DC. But in AC, the current will flow in both directions. For some time, the current will be flowing in this direction, and for some other time, the current will be flowing in the opposite direction. So that is why you call it as alternating current. It alternates the direction. So you represent, this is DC, you represent AC with this symbol. Okay. This I call as V or your epsilon, E. I can use any symbol, but this is for AC. This is the symbol you use. Which means that if you have a circuit, like I have a circuit, I have the source. This is the AC voltage source. And if we connect a resistor here, for some time the current will flow in this direction, and for some other time then the current will flow in this direction. So the current will alternate directions. It will flow like this and also flow like that. So this is what we call as AC. So with this brief introduction, we will get into the lesson. Let's start this lesson by talking about a mathematical concept. the mean value of a function, or the average value function. Let us suppose that you are going to start from here and then reach E road. Okay? You have a distance of roughly 40 kilometers between these two places. And let us suppose that you are starting with the speed 0 and then you keep increasing your speed constantly till you reach E road. So the graph of that activity would look something like this. So I have this one. So this is my speed, velocity, and this is my time. Okay, I start from 0 speed and then I constantly increase the speed. It's constantly increasing, so it's a straight line. And my speed is increasing all the time. My speed is increasing all the time. And now at this time, maybe we call this t now, some capital T time, then I have reached E road. So when I reach E road, I have this speed. I constantly increase my speed and then I reach E road speed. So if I find the area under this curve, this will be equal to the distance between this place and that place, between Gobi and E road. Okay? So this would be the area of this triangle got here would be 40 kilometers. Okay. Okay. So this is what one guy does. This guy starts from a speed of 0 and then reaches E road by constantly increasing his speed. And it takes a certain time to reach that place. There is another guy who starts with a constant speed. He is not changing his speed at all. As he starts, he reaches a certain speed. And then he keeps going on at the same speed without changing the speed at all. And he also reaches E road in the same time. At the same time, this guy starts with a constant speed and continues with that speed till he reaches E road. So, we also know that this curve, this area, this must also be equal to that area, because that area is going to give you the distance you have traveled. So you started at this speed and then you continued. So this area must give you the distance between Gobi and E road. And there is another guy who started at 0 speed and then he kept on increasing the speed till he reached E road. So as he reached E road, then he had this speed. But then he also reached E road in the same time as this guy. Okay. So what we say now is that instead of constantly accelerating, if that guy had gone like this guy with the same speed, at that speed, then he would have reached E road in the same time. So we say that this is the average speed of this guy. This is person 1, this is person 2. But person 1 has an average speed which is equal to the speed of person 2. The average or mean speed. Mean meaning average. So this is the idea we are going to use. I consider a very simple case of constant acceleration. Suppose it's another guy who started from 0 and then he varied his speed and finally he reached E road, and when he reached E road he also had 0 speed. Okay. So he started from 0 and like he kept increasing, changing his speed, and finally as he reached E road, then he has brought the speed down to 0. Okay. So now if this is V, right? This is V and this is T. And if I find the area of this curve, then that also will give me the distance between Gobi and E road. So how do you find the average speed for this guy? Well, the same way I did the average speed for this guy. So what I will do here is that I will take this time t, okay, then I will call this as capital T, and take this time t, and I am going to calculate the speed with which I should travel to reach E road in the same time. Okay? So this time I may get a different value. Okay? Like this. So this is what has actually happened. The black one is what has actually happened. He is varying the speed all the time. And this is what you have calculated to be the mean speed or the average speed. So what you are saying by this number is that instead of going like this, if this guy had gone with the same speed for the same time, then he would have covered the same distance. So this single number represents all the other numbers you have along the y-axis. The single number that you have on the y-axis is representative of all the other numbers. So that is what we call as a mean speed in this case. Okay. So how do you find this, and how can I come up with a mathematical expression for it? What have I said? This area, the area under the blue curve, is equal to the area under the black curve. So the first thing is that if I want to find the mean speed, what do I know? I know that this mean speed V, into this time, the same time, Vt must be equal to this area, because you know this is a very straightforward calculation. It's just a rectangle. So length multiplied by breadth will give me area. So V into T. But this is a complex curve, and that area can be calculated using what? Using integration, because you don't have you can't do it in a straightforward fashion. You need to integrate it, because you will take all these small areas and then add them all together. So you require integration to do it. So that would be integral of this curve, right? Like V. Okay. So this curve V, the velocity and the speed, is actually a function of time, some function of time, because at some time you have some value, some other time you have some other value, yet other time, it's another time you have it's another value. So this is a function of time. So you say that V of t into dt, and then you have to integrate it between limits. What limits? 0 and t. So you start from time 0 and then you go to time t. So this area must be equal to this simple area. Then what is V? Which is the average speed. And the mean value is equal to 1 by t into this number, 0 to t, V of t dt. So this is a very important equation. I can generalize it. I've used V and T. I can generalize this with what? With y and x, because I have an x-axis and I have a y-axis. So if I can do it for speed and time, I can do it for anything along the y-axis and anything along the x-axis. So y versus x. So I can do the same thing for any y and any x. So I'm going to generalize this. So I'm going to say this is y average. Average value of y, or y mean, okay, is equal to, then this is going to be 1 by x. Notice that I am not using lowercase x, I am using capital X because it's going to be some value. Lowercase x is a variable, but now you see you have a number for it. So that is what I mean by x, 1 by x. And this would be 0 to x, that x. And you will have y as a function of x. Y as a function of x. And then dx. So this is the general idea. So when you do this, you take any function, any random function, like that. Any random function. Then you find the area under this curve, and then you see you have this range from 0 to something, okay? It doesn't have to be 0, it can start from some value to some other value. Okay? X 0 to some x here, okay? And you find the area, and divide it by this number, then you get what is called as the mean value for this. So this again ends with the same number. So this area will be equal to that area. So in that case, you call this as the mean value of the function. So you call this the mean value. Mean. I want you to understand this. If you understand this, then we can proceed with the lesson. So we are going to use that idea now to calculate the mean value or the average value of the sine function and also a sine squared function. Okay. Let me first draw the graph of the sine function. Let's suppose that I take this function sine p or y is equal to sine omega t. I would have this as theta itself, or sine x, sine omega t, it doesn't matter. Okay? For all that, you will have the same shape. So this function is going to be like this. Okay, so this is the y value and this is the t value. Okay. So what do you know? In one period, let's capital T, one period, then the sine curve will complete one round, I should say. Okay. So I start from here. This would be so one cycle is completed in time t. This is a period, a time period of oscillation, right? So it oscillates, goes up and down, and in one time period it will complete one oscillation, one round. Okay, so it will start from 0, then it will, this will be plus 1 and this will be minus 1. Okay, and this is actually t by 2 and that is t. In half time, then it will give 1. Okay. Now the question is, what is the mean value of the sine function, just as we discussed. Okay. So the mean value of sine function depends on the time frame. Are you going to do it for the complete cycle, or are you going to do it for only the half cycle, or are you going to do it for only this much, maybe like for the first 40 millimeters? How much are you going to do it? So t by 8 or something, like how much are you going to get? That's the thing. Depends on what, that you can clearly see. Notice it. If I take this as my graph, then how would I find the mean value? I will find this area, and if I divide that by t by 2, then I will get the mean value for this, right? So it is. And if I choose only this area, up till here, just 92 or something, okay, to 90. If I do just this, only from here to there, then it will be t by 4. So if I find this area, and I can divide it by t by 4. Okay. In this case, I will get the same thing, it's symmetrical, but you get the idea. You get what I'm trying to convey here. Okay. So, but that would be different if I do it for even half of this. So if I do it for, this is t by 2, t by 4. If I do it for t by 8, t by 4, so this would be t by 8, right? 45 degrees. So t by 8. You notice here, if you were to calculate the average, the mean value and the average value for this area, then it will be somewhere here. It will be different. Okay. So likewise, if you were to calculate the average for one cycle till t, what is it going to be? What is the average value? See, up till here, you see you have this value, maybe this was your average value, and here maybe this was the average value. Okay, for both t4 and t2, t by 2, when they are symmetrical, then you may have this as your average value. This is the average value, and for this period, and this would be the average value for this period. So you can see that it is different. You can visualize it. I'll do this maybe and go with a different color for this. For this period, this would be the average value. And for this period, this would be the average value. What is the average value if you take the entire period? The whole t. What I'm going to get here? Well, these are all positive values, and this is the same time, so I'll get some positive number here. Notice this. This is all negative, and I'm going to integrate for the same time. Here, this half. This is negative, and this is positive. This is going to give me a negative area, and this will give me the positive area. Because these two curves are symmetric, then this positive area will cancel this negative area, and the net area of this curve will be 0 for me. So the net area is 0. If the net area is 0 over this period, or the one complete cycle, then the average value will also be 0. Because what is the average value or the mean value? The area divided by the time. If the area is 0, then if you divide it by the time, then the mean value will also be 0. Notice how it changes. The mean value had some number over this time frame. A different positive number over this time frame. And clearly, if I take an capital T, for example, if I had just done that, say it's T by 2t, if I done that, then the mean value will have a different value, because you notice that this is a positive value, this is a negative value, but this is a smaller value than this one. So you have net positive. So for this period, you would probably have had something smaller than this. Something like this. You probably would have had something like this. And if I take the entire cycle, and the mean value becomes 0, because this area would be balanced by this area. This is a positive, this is negative. So the net area is 0. If we divide that net area by time t, then I have an average value of 0. So the average value of a sine function over, you can't say average value, you can't assign this single average value. I told you, there are many different average values here, depending on how big the time frame you have taken. You have to be careful about the time frame. So, let me say this. The average value of a sine function over one cycle is 0. That's important. The average value over one cycle is 0. If you take the average value less than one cycle, it won't be 0. So for every multiple of that cycle, 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles, 6 cycles, 1000 cycles, 1 million cycles, the average value will be 0. I want you to understand this. So this is for the sine curve. Okay, so how do I do this? Let's mathematically. This I've shown you physically. We can derive that mathematically also. So it's like this. So y is equal to sine omega t. That's a function. Then what's the area? Any dx, any dy I should say. Any dy is equal to any area, I say. I don't need dy here, I need any area. If we take this, we want to find this area, this small, for a very small dt. This is dt. It's a very small time interval. We want to find area. Then I can say that this y value does not change over the time t, because it's very small. So I can assume that to be constant. So that dA, that small area, this is called a small area, is equal to y to dt. Okay? And that is equal to sine omega t dt. Okay? Now if you want to integrate it from 0 to t, let's say minus 1. So the area is equal to integral of dA. Okay? This is equal to integral sine omega t dt. dt is the quantity that is changing. It is changing from 0 to t. Okay? That's what it is. Okay, so what would I get here? I would get, this is going to be equal to sine omega t is minus cos omega t. So minus cos omega t is going to be 0 to t. Okay? So that will give me minus cos omega into t. So omega into t is what would I get here? Omega is 2 pi f, right? Let's say cos 2 pi by t, that is omega. Now t, for t I am going to put a t here. That's right. Then minus of minus, this is 1, minus of minus cos 2 pi by t, but for this I am going to put 0. So this is 0 here. So that is 1. Okay. So this is gone. So cos 2 pi is 0, right? Cos 2 pi is 0 here. So cos 0 is 1, so you get minus 1, and then minus of, this is also 1, minus of minus 1, so minus 1 plus 1 is equal to 0. So the area is 0. So the area is 0, then what's the average value? Y mean or Y average is equal to that area is divided by the time over which this area is calculated. So, sorry, the length over which the area is calculated, right? So the x length. So that's going to be t, V by t. We saw this. So it's 0 by t, 0. So the average value of this is 0. So it is not just true for just the sine function alone. Even if you use a cos function, you will get the same value. So instead of y is equal to sine omega t, if you take y is equal to cos omega t, and if you integrate that function, and if you substitute that, then you will get 0. So what you need to understand is that the average value of a sine function over one cycle, one full cycle, is 0. That's important. Over one full cycle is 0. Okay. What about the sine squared function? Let's see. I'm going to do the same thing, but now this time I'm going to take the sine squared function. So when you, what is sine squared function? It's like this, right? So sine squared function will be something like this. Y is equal to sine squared omega t or something. That's the sine squared function. So you can, so this is equal to sine omega t into sine omega t. So notice that it is always positive. You will never get a negative number for this, for sine function. Why? Because if this is positive, this will also be positive. But t will be the same. So this is positive, this will be positive. So it's a positive number. But if this is negative, when it comes here, this will also be negative. So the square of, when you multiply a negative quantity with another negative quantity, then you get positive. So over one full cycle, you will still have a positive area. You will never have a negative area. Okay? So this area, it's going to be something like this. For the first half, square, the sine, it's not sine square, and then the next half also will have same thing. Okay. Okay. One is very smaller, but you can see that they must be at the same height. Okay. So this is p by 2. This is t. That's the difference. The sine function is going to look like this, but the sine squared function is going to look like this. So one area will never be balanced by another area. So you will always get a positive number. For whatever time you take, you will get a positive number. Well, that number could be different, but it is always a positive number. It will never become 0, because all the numbers involved here are all positive. So that's what I want you to see. Now we can do the math. Okay, so I'm going to approach it the same way. So y is equal to sine squared omega t. So if I take this small area, okay, so that would be dA is going to be equal to y dt, and that is equal to sine squared omega t dt. And what should I do now? I need to integrate over the entire period, right? So the area, the actual area is equal to integral of that small area. So that would give me the integral sine squared omega t dt. I'm going to start from 0 and then go the full cycle. So 0 to t. So that's what I will do now. So since this is it, I know that I cannot integrate it straight away because sine squared function cannot be integrated straight away. So you need to use a trigonometric identity. So what is that identity? We know that sine squared theta is equal to 1 minus cos 2 theta by 2. This is identity we will use here. If I do that, you can see that is going to be 0 to t, and this would be 1 minus cos 2 omega t. Omega t is theta, and that divided by 2 and then dt. Okay, so I can take 1 by 2 out. So 1 by 2 can be taken out. I got 0 to t. Then if I expand it, it will be just dt. Okay, it's one part. And minus again 0 to t cos 2 omega t dt. So this will give me 1 by 2 out, and this would be simply t, right? So t 0 to t, and here this is going to be minus sine 2 omega t by 2 omega. This will be 0 to t. Clearly, if you put this is equal to 2 pi by t, and if I multiply it by t, then t, capital T will cancel, and I'll get 2 into 2 pi will be 4 pi. So sine 4 pi will be 0. That value is 0. So this limit will be 0, and if I substitute 0 straight away, that also will be 0. So this function, the value of this limit will be 0. So that is why I said whether it is a sine function or a cos function, as we got here, it would be 0. The average value of it over one full cycle will be 0. We have seen both of them now. Okay, so this will be 0. So I am left with only this. So half, then t 0 to t. So this is what I get. Okay, so what do I get now? This is 0. So if I substitute this, then I get 0, t will be t by 2, and that will be 0. So the area is t by 2. So the area of the sine squared omega t function over one complete cycle is t by 2. Okay, so how do you find the mean value of y? That is easy. I'm going to make use of this space now. That's easy. What's the mean value? Y average is equal to this area divided by this time. Okay, this the x-axis, right? So over which the area has been calculated. So a by t, total t. So that is going to be equal to t by 2 divided by t. So the average value for this function, the sine function, is 1 by 2. Sine squared function. So you can see that the average value of the sine function over one complete cycle is 0, and the average value of the sine squared function over one complete cycle is 1 by 2. I want you to remember this because this is critical as we go forward.